Hi, I'm Maha Malik, and through this video, I'm going to take you on a roadmap to understand quality function deployment. In order to understand quality function deployment, let's start with the definition. What is QFD? Quality function deployment is a structured approach to defining customer needs, which is the voice of the customer, or requirements, and then translating them into specific plans to produce products to meet those needs. QFD identifies customer desires, then it identifies the importance of those desires, followed by the identification of engineering characteristics which may be relevant to those desires. Then it correlates the two and allows for verification of those correlations and then assigns objectives and priorities for the system requirement. We'll start off with the definition of. Our next step will be to understand the stages of QFD. There are four phases of product development. The first stage is product planning, which includes demands, substitute quality characteristics, which will be obtained through customer insights. The second phase is of parts deployment, which includes concept selection and significant parts and significant part characteristics. The third phase will be of process planning, which includes the concept selection, which is the process selection, and significant process operations and parameters. The last stage is of production planning. The production planning stage includes control requirements, maintenance requirements, mistake proofing, and education and training. Then we'll move up to the next stage. Once the customer needs are identified, then what's next? Then we'll understand the House of Quality matrix. But what is House of Quality? House of Quality is a diagram resembling a house used for designing the relationship between customer desires and the firm or product capabilities. It is a part of the quality function deployment and it utilizes a planning matrix to relate what the customer wants to how a firm is going to meet those wants. The basic structure is a table with what's as the tables on the left and hows across the top. Now, we look for the House of Quality matrix steps. Firstly, we'll identify the customer wants, which can be done through surveys, interviews, or customer insights. The next step will be identify how products will satisfy consumer. Then the third step will be the identification of relationship between firms, hows. The fourth step will be to develop important ratings, followed by the fifth step of evaluation of competing brands, and the last stage will be the determination of the desirable technical attributes. In order to better understand the House of Quality matrix, we look at a very basic model with customer wants on the very left side, where next to it ranks of preferences will be given. Then the second stage would be the product house, then the interrelationships and the relationship matrix. Then the fifth stage will be the importance ratings, which will be done through aggregate. Then in the sixth step, what we'll do is analysis of competitors, and in the seventh stage we'll do the technical attributes and their evaluation. We have these steps demonstrated in a diagram with list of consumer what's, list of technical descriptors hows, develop a relationship matrix between what and hows, then develop an interrelations HIP matrix between hows, then we'll do the competitive assessments between the competitive brands, and then develop prioritized customer requirements, and lastly develop prioritized technical descriptors. Now, how to explain house of quality matrix. We'll take an example to build a house of quality matrix for development of a new camera design. So, as we said, the customer wants will come on the very left side. For example, for a new camera design, the customer wants will be lightweight, easy to use, reliable, easy to hold steady, and no double exposure. Now it will be rated according to the preference of customer importance rating, while 5 being the highest and 1 being the lowest. The 5 rating will be given to the reliability, while 4 to the easy use, 3 to the lightweight, easy to hold will be given a score or importance of 2, and no double exposure will be given a 1 rating. Now, how will the company do it? And these are the factors of how to do it. Low electricity requirements, aluminum components, autofocus, auto exposure, auto firm advance, and ergonomic design. Now, we have these relationship scales. While this symbol represents high relationship, which will be given a score of 5, this symbol represents medium relationship, which will be given a score of 3. And this symbol represents very low relationship, which will be given a symbol and a rating of 1. Now, let's look at the first column. There exists a very low relationship between lightweight and low electricity requirements. If the camera is lightweight, it will not have a correlation or any impact on the low electricity requirements. If the company wants to have no double exposure, then it will have to use autofilm advance. That's why it represents high relationship. If the company wants easy to hold steady and wants to fulfill this want, they will have to develop an ergonomic design. Now we'll calculate the weighted ratings. Now the point is how to do it. Let's look at the first column. A very low relationship will give a score of 1, and we'll multiply 1 with 3 as depicted over here, which will be added to the next relationship, the correlation of easy to use and low electricity. The low relationship will have a score of 1, which will be multiplied with 4 and added to the relationship of reliability with low electricity of a medium relationship with a score of 3, which will be multiplied with 5 rating scale. And as we can see, the calculation shown over here will give our importance rating aggregate of 22. Similarly, if in a column there's just one relationship and correlation represented, how we'll do it? The medium relationship between the lightweight and the aluminum components represents a score of 3. And 3 multiplied by 3 will give us our rating importance of 9. And this is how our importance rating will be calculated. Now we look at the competitors. G represents good possession, F represents fair possession, and poor representation and relationship is depicted through P. Our company is doing good as compared to company A while doing poor as compared to company B if we introduce lightweight. And this is how this whole competitive advantage and competition analysis is constructed. Then the last step will be the determination of technical evaluation based on technical attributes. Now let's look at the summary. Quality control deployment has the following benefits. It has the orderly way of obtaining information and presenting it. It has shorter product development cycle, considerably reduced startup cost, fewer engineering changes, reduced chance of oversights during design process, environment of teamwork, consensus decisions, and preserves everything in writing. So this was a little summary of quality function deployment. I hope you understand it. I hope this video was able to enhance your understanding about quality function deployment and how the house of quality works and the matrix is constructed. Thank you.